Hello. So today we'll take the example for the quicksort algorithm. So already we have learned what is the quicksort. The quicksort works on divide and conquer principle. First it partitions the list of items into two sublists based on a pivot element. All elements in the first sublist are arranged to be smaller than the pivot, while all elements in the second sublist are arranged to be larger than the pivot. The same partitioning and arranging process is performed repeatedly on the resulting sublist until the whole list of items are sorted. Today we'll see one simple example like how to implement the concept of quicksort. So first is we need to consider the three variables. One is we are calling as a pivot, that is the first position from a list we are considering as a pivot. Afterwards we are considering one more variable, that is the left, or we are calling as a L, and it is going to be pointed to the first position element. Afterwards we are considering that is the right, that is the last position element from a given list. Like consider if you are having the elements like 5, 3, 1, 4 and 7, and for this element if we want to apply the quick sort, so the first element from a given list we are calling as a pivot, also the first position element we are calling as a left, and the last position element we are calling as a right. Now the thing is the working of left as well as the working of right. Working of left is if less than pivot, then we need to move to the right. The left, that is the L, it will be moved to the right. Also the right, that is the R, if greater than pivot, then move to the left. It means that the value of R, it is greater than pivot. In that case we need to move to the left side. Next thing is if both left and right does not match, in that case we need to swap left with the right. Also, if we are having the condition like left is greater than or equal to right, in that case the pivot point where they meet a new point. So like consider after solving this, if you will get like this 3, 1, 4, 5, 7, and in this particular this is the pivot. Here if you will get left as well as the right, in that case this particular position we can say it is the sorted position. So we can say this is the pivot, and left side of the pivot we are having the smallest element, and right side of the pivot we are having the largest element than this particular element. So in that case again the quick sort we need to apply over left subarray as well as we need to apply on the right subarray. So like that the quick sort algorithm it is going to be work. So let us see one simple example based on this. So this is the array list we are having like 3, 12, 5, 19, 1 and 17, and all the array elements are in unsorted order. Now here we want to apply the quick sort, and we need to sort these elements into the ascending order. So in previous algorithm we have checked, we need to consider the three elements. One is the pivot, second one is the left, and third one is the right. So the first position element we are calling as a pivot. Also the left, the first element we are going to be calling as a left, and the last element we are calling as a right. Now the thing is, what is the work of left and right? If the left, that is the L, is less than pivot, then we need to move to the right. And if the right, that is R, it is a greater than pivot, and in that case we need to move to the left. So here we can check the left and pivot at the same position, the same value we are having, then directly we will consider for the right. So here the value of right, that is 17, it is greater than pivot. In that case we need to move to the left side. So R it will be comes here. Again we can check the value of right, that's R. It is a less than pivot. In that case we are not moving anywhere. So here we got the value of left as well as we got the value of right. In that case we need to do the swap, that is the left with the right. So here 1 it will becomes, this is the 12, this is the 5, this is the 19, 3 it will comes here. This is the pivot element right now we have considered, and 17. Now this is the left position, and here we are having the right position. So again, the value of pivot and right, the same value it will be there. Then we can go for the left. So what is the rule for the left? It is if it is less than pivot, we need to move to the right. So the value of left is 1. The value of pivot is 3. In that case, 1 is less than 3. In that case, we need to move to the right. So here left it will becomes again 12. It is going to be compared with the pivot element, that is the 3. So 12 it is greater than pivot. In that case, we are not moving anywhere. So again here we got the value for the left as well as the right. In that case, we need to do the swap. So 1 it will becomes here, 12 instead of 12, 3 it will becomes here. This is the 5, 19, 12 it will becomes here, and this is the 17. And this is we are having the pivot element. Right now here we are having the left, and here we are having the right. Now again left and pivot at the same position will go for the right. So value of the right, it is greater than pivot. In that case, we can move to the left side. So right it will becomes here. Again value of right, it is greater than pivot. Again will comes to the left side. R it will becomes here. Again the value of right, it is compared with the pivot, and the value of right, it is greater than pivot. In that case, R it will be comes here. Now we can say that left and right at the same position. So the 3 we can consider it as a pivot. So directly we can write 1. This is the 3, 5, 19, 12 and 17. Right now 3 it is their correct position. Into the left side we are having the smallest element, and into the right side we are having the greatest element. So we got the two subarrays. One is the left subarray, another one is the right subarray. Again the same quicksort algorithm we are applying on the left subarray as well as the right subarray. So here this is the pivot, this is the left, this is the right. So both are having the same position, and also we are having a single element. So one also we can say that it is their correct position. Now we need to apply the quicksort on the right subarray. So this one we are going to be considering as a pivot, this one we are considering as a left, and this one we are considering as a right. Again we need to move left as well as the right. So here left and pivot at the same position. So we'll go for the right. The value of right, it is greater than pivot. In that case, we need to move to the left side. So R it will becomes here. Again the value of right, it is greater than pivot. So R it will be comes here. Again the value of R, it is greater than pivot. So R it will be comes here. Now here both pivot, that is R, L, are at the same position. So we can say that 5 it is going to be sorted. So we can check into the right side, all the elements are in sorted order. So the remaining subarray is 19, 12 and 17. So again we are going to be applying the quick sort on this remaining arrays. So here this one we are calling as a pivot, this one that is the left, and this one we are calling as a right. So pivot and left at the same position will go for the right. So right, there is a 17, it is the smallest element than 19. So we got the element like left as well as the right. So here we need to do the swap. That is 17 it will becomes here. This is the 12, this is the 19, and this one we are considering as a pivot. So this one we are calling as a left, this one we are calling as a right. Now pivot and right both are same position. So we'll go for the left. So 17 it is the smallest than 19. So left it will be comes to this particular position. So 12 it is the smallest than 19. In that case will come to this particular location. Now we can say that the left and right both are the same position. So in that case 19 will got here. So 19 it is going to fix their position, and the remaining elements are 17 and 12. So in the right subarray there is no elements are present. Only the left subarray we are having the 17 and 12. So again we are applying the quicksort algorithm on this 17 and 12. So the remaining elements are, that is 17, 12. So like consider this one we are calling as a pivot, this one we are calling as a left, this one we are calling as a right. So pivot and left both are at same position. So we'll move for the next element, that is a 12. So here, right, that's a 12. It is the smallest than 17. So there is no need to do the move. So in that case, we'll swap both L as well as the R. So 12 it will becomes here, 17 it will be goes here. Now this is the pivot and this is the left position, this is the right position. Now right and pivot at the same position. In that case, we'll move for the left. So the value for the left, it is smaller than 17. That is the 12, it's smaller than 17. In that case, we'll move to the right side. So left it will becomes here. Now left and right at the same position. So in that case, 17, this element it is going to be fixed. Now the remaining element is 12. So only the single element is there. So this one also we can consider as a pivot element. Now first we got the 1, afterwards we got the 3, afterwards we got the 5, afterwards we are having that is 12, and now we are having that is 17, and last element that is we are having that is the 19. So now here we can say all the elements are in sorted order. So like that we are going to apply the quick sort algorithm. Thank you.